Welcome everyone to the March 1st today math seminar here at JRCC. My name is Brian Hadley, and I'm really excited to talk about bracketology, math, and March Madness. But I changed this last word from madness to mathness because, well, it sounds cool. That's not an original idea to me. I actually stole that from a friend of mine, which I'll talk about here in a moment. Okay, so here's the big show, right? This is the bracket. There are 68 teams here in a couple weeks that are going to compete for the final spot, which is the championship. There's a lot going on with this bracket, and so the term bracketology generally refers to the idea that I'm going to have all of these populated by teams on the corner, and then my job is to correctly fill in as many wins as possible. And usually, the way we think about this game of bracketology is, there are variations, but usually the number of correct games I get for the first round gets 1 point, and for the second round gets 2 points, and for the third round gets 3 points, and so on and so forth. And there's some variations to that, but that's the basic idea. And then usually, you pick a final score of the championship game in case there's any ties, right? And so that really is the thing, as it turns out, that is the killer, is picking the final score. I often can say, hey, I've done just as well as anyone else has done, but then I didn't do as well in the final score. So it's harder than it could be even with lots of math because of that final score component. But the idea is that if I get more picks right than the people I'm playing against in bracketology, I'll beat them, right? And that's why we play games, is to win, right? Or else, what are we doing here, yeah? So that's complicated, so let's look at a very, very, very small version of effectively the Final Four version. And I have 4 teams, A, B, C, and D, that are gonna play against each other. And let's say over in the west part of the bracket, Team A wins, and over in the east part of the bracket, Team C wins. And so that's 2 games been played, and then a third game gets played to figure out who the champion is. And I've decided that Team A should win, yeah? And so what I did was call this possible combination of winners ACA. So A, C, and then A, ACA. That's what I called it, all right? That's the idea. And then I chose again and said, well, what happens if A won the first game and C won the second game, and then C won overall? And I called that ACC, right? So A, and then C, and C's the champion. So I put those there. And then I do it for all of them. So this is all the possibilities, right? So for example, B won in the west, C won in the east, and then B is the overall champion, right? So that's the 8 total possibilities that you could get. So there you go, 8, right? So I took 8 and said, all right, instead of saying the number 8 as 8, say the number 8 as 2 raised to the 3rd. And then you notice that, well, that's the same as 2 raised to the 4th minus 1, 2 to the 4th minus 1, so that's 3. And then I make a conjecture that n, if that stands for the number of teams, and then minus 1, that tells me. So I had 4 teams, and minus 1 makes 3, so number of teams minus 1 is a third, and then that's the number of possibilities I get, right? That's the idea. Okay, so if that was the Final Four and that was all I had, I have a 1 in 8 chance of guessing correctly the bracket. Well, I can do that in an afternoon. I can fill out all 8, right? No problem, okay. Well, there are 64 teams. Now you say, wait a minute, Brian, you just said there were 68 teams. Okay, there is 68 teams, but no one cares about what they call the first 4. They literally don't care. None of the brackets care about it. No one cares, right? Those are just sort of play-in games. They call them the first 4. And so there's really 64 teams in the March Madness bracketology. So if I take 64, the number of teams n, and I minus 1, I get 63. So that's 1 in raised to the 63rd. That's that number, which is really big. And John Dersh and I were discussing what that number was by name a few days ago, and I've forgotten promptly what that number is, but it's really big, right? So it's approximately 9.22 followed by 18 zeros. Right? So it's really, really big. Yeah? Well, all right. I can come to that conclusion by this sort of induction proof, right? That my little model of 8 teams, or 4 teams, 8 possibility is the same as my big model of 64 teams. But let's do a test case. All right. So if B wins, and I know for sure that B is going to win in A versus B, that tells me a lot about something about my model in this small scenario. A plays B, and I know for sure that B is going to win. What does that allow me to do with all of my list of stuff? Anywhere I see A, I can cross it out, right? Because I know for sure that A is not going to win. So anything where I see A, I take, it's gone. How many do I have left? Just 4. Okay? So back to my trying to create some sense of what I'm trying to do here. Now I have 4 possibilities. 2 to the second is 4. So then I think 2 to the 4th minus 1 is also 2 to the squared. So then if I say 2 to the n number of teams minus k, where k is the number of games that I know the outcome to, minus 1. So in this case, I had 4 teams minus 1 game that I knew the outcome to, the A-B game, and then the still minus 1. All right? So let's look. If I had 2 to the 64 teams minus k minus 1, and I knew none of the games, completely unaware of how the outcome of any game is going to be, then I get 2 to the 63rd, right? So this is this number. What if I knew all the games? I have 2 to the 64 minus 63, because I know all 63 games, their outcome, minus 1, well, that's 2 to the 0. I have a 1 in 1 chance. Yeah? I mean, that's what we should do. Let's just do that, right? Okay. Here's a question. Can we know the outcome of a game before it happens? This word, no. Wow. This is a better word. Predict, right? Can we predict the outcome? Well, of course we can predict the outcome. But the question is our prediction have any value, right? I can predict the outcomes all day long, but if I don't know what I'm talking about, what good does that do, right? Okay, so with any certainty, really. So can we predict with any certainty the outcome of a game before it happens? And the answer is yeah, we can. Yeah, we do it. They do it, we will do it, right? Okay, we'll do it with ranking methods. So we make a rank, we put a rank together, and that predicts the outcomes of games. There are a couple of points to make about ranking methods. Number one is their opinions. Ranking methods are opinions, right? They're opinions. Some people's opinions are better than others, but they're still opinions. And they're really an estimation of quality. It's an estimation. They're correct many times, but often not so much. The NCAA uses a ranking method to build the tournament bracket. They themselves use a ranking method to figure out what they do. They use a version of the Delphi method, and the Delphi comes named after the Oracle of Delphi. I think this is Pytha, I think is how you say that. And she was the priestess of the temple in Delphi, so it gets named that name. So it takes individual experts, and it pools their knowledge together. And the idea is that all of these experts get together and pool their knowledge, and it enhances individual judgment, right? And it's like the smoke-filled room, like the caucus idea, right? So you have a bunch of, like this old traditional story, like a bunch of old people sitting around a room smoking their cigars, arguing over who should be where in the tournament. That's the idea, right? This caucus idea. Okay, so this is right from the rules. So committee members, this Delphi membership, have a wide range of observations, consultations, and data resources that they use throughout the season. They're supposed to make discussion and deliberation based off of their opinions. They do this through watching games, this regional advisory rankings, box scores, head-to-head results, results of various common opponents, in-balance conference schedules and results, overall non-conference strength of schedule, quality of wins and losses, and various computer metrics. Various, right? Which one? I don't know, various. Right? So basically what this says is, if you're a committee member, you're supposed to just do what you think is best, based on whatever resources you think is best, because you're an expert. Each of the 12 committee members uses these various resources to form their own opinion, right? The Delphi opinion. And it says the committee's consensus positions on the selection and the team seeding, which of seeding is a fancy way of saying ranking. Okay? All right, here are the 12 folks responsible for the men's bracket this year. And here are the 12 folks responsible for the women's bracket this year. All right? All of those people are very important people in the world of college sports, for sure, absolutely. Okay, continuing on, each committee member receives this initial ballot, and the first column, they identify not more than 36 teams. Why 36? Well, there's two things that go on. There's 32 conferences, so 32 teams get an automatic bid into the tournament. And then on top of that, there are 36 additional teams. So they pick 36 teams that, in their opinion, should be at large. And it says, don't consider whether or not they're going to make it as an automatic qualifier or not. Just put your top 36 down. And then in the second column, identify all teams endlessly that you think should be in the bracket. And the only maximum limit in the second column is that they should get serious consideration. Right? So who shouldn't get serious consideration this year? Well, my alma mater, WMU. They've won 4 games all season, maybe 5. I forget what they did last night. It's less than 7, yeah? They don't get serious consideration. But if they rally next week and win the MAC championship, we'll see them in the tournament, yeah? But they're not, maybe. They're not gonna. Okay, but let's say they did, right? So they would get in on the automatic qualifier. So they shouldn't be on anyone's list because they shouldn't get serious consideration, all right? So here's the idea. There's these 32 champions of each conference, and then on top of that, there's these 36 at-large people from the committee's work. So that's a total of 68. And then they do this 1 through 68 ranking. There's 3 pages of rules and regulations on how they're supposed to, after they pick the 68, how they put them in the seeds. They call that the true seed, okay? So 1 through 68, that's called the true seed, the true ranking from the committee. Then what happens is, because they have this true seed, 1 through 68, the relative qualitative assessment of the field is in descending order, and it's used to assess competitive balance of the top teams across the 4 regions of the championship. And then clearly that implies that this may preclude a team from being placed in its true seeded position in the bracket. In other words, this is a fancy way of saying, no one wants to watch a Final Four, which is primetime television, billions with a B of dollars at stake, when it's the worst teams in the country. So the idea is, the bracket, because of this competitive balance, the bracket has the best teams put balanced throughout the tournament, because we want the final games to be the most interesting, yeah? Let's say my alma mater made it, and they're here, and then no one else in the bracket is any good, and then they make it to the championship game, and they're a terrible team. Well, no one wants to see that. They want to see good basketball at the end, right? And so we put a balance of talent and balance of success across the entire bracket. Well, back to the 68 business. So they play this 18 playoff, these play-in games, and what they do is take the 4 lowest seeded automatic qualifiers. So if Western happened to pull it out this year and won their championship, they would be in one of these, right? They're very low seeded if they were to happen to do it. And then they play the 4 lowest seeded at-large teams. And the winners of those get to go into what they call the dance, right? The actual field of 64. All right, so there'll be a total of 64 teams. And then the idea is, based on this balanced seeding, that the best teams are 1 seeds in each of the 4 regions in some order. And then the second best, so then the next 4, 5, and 6 team would be the next top seeds. They'd be down here in the 2. And then the next in the 3, and the next in the 4. And so the idea is, in a perfect world, at the top and the bottom of each region of the bracket, you'd have the best team playing the worst team, and the second best team playing the second worst team, right? The 1 in 16 game and the 2 in 15 game. And then when you get here in the middle, you kind of have more balance because you're getting those numbers closer and closer to each other, right? That's the idea. Okay, so let's look at 1 versus 16 seeds. Now again, in 1985, the NCAA went from its current format that they had then to a 64-team field. In that time, from 85 to 2018, no 16 seed ever beat a number 1 seed. Always 16 seeds, always lost to number 1 seeds. Well, then in 2018, UMBC shocked the world and beat the University of Virginia. This team, this Virginia Cavaliers, was picked in almost all the experts bracket to win the whole entire tournament. They shouldn't have not just only been the 1 seed in their region. Most experts picked them to be the top team of all, right? All the sports books had them as the lowest odds team as far as payout because everyone assumed they would win, and they didn't make it out of the first game. It shocked the basketball world. It was crazy. People didn't know what to make of it. A lot of ink was put on pages. And look at the score. It wasn't a close game. It was a blowout. Everybody was gone crazy. Well, in retrospect, it seems as though the coaching staff apparently didn't do that good of a job of telling their players, don't look beyond the first round. They were talking about, think about the championship. Get a good night's rest because tomorrow's game is going to be important. And they forgot it all. There's even some rumors that they really didn't even do any scouting on this team. And this team beat them. So, one time, that happened. So it's 1 in 148. Well, 1 in 148 is around 60-something percent. Or, no, sorry, not 60-something percent. 0.06%, somewhere around there, right? Okay. So, those 4 games in each bracket, in each part of the bracket, each region, there are 4 of those, 1 in 16, from the west, the southwest, the northeast, and the southeast. So there are 4 games there. So I'm going to say, with pretty good insurance, that I know the outcome of those 4 games. Could I be wrong? I mean, that one time I would have been. And that year I was, right? But I still got 3 out of those 4, yeah? Okay. So I'm going to say that 4 of those games, 64 teams, 4 known outcomes, still -1, is 2 to the 59, which is still a really big number, right? But notice, this digit changed from an 18 to a 17, which is a savings of that. That's a lot. Is it important? I mean, it's statistically significant, but great. I still haven't built a perfect bracket, yeah? Okay. Historically, experts correctly pick around 31 games, consistently around 31 games. Around half, right? So 63 games, they divided by 2 is 31.5, so around half, somewhere around there. 30 on bad years, 32, 33 on better years. So let's look. If historically the experts, so these would be people that you see on TV, famously like a Dick Vitale, others from ESPN, they're very, this is what they do, right? They sit all season long, they're sports writers, they're commentators, they're experts, right? And so they pick these, they put out brackets, right? So historically they get that. Well, look at this. This is the real number, historically, right? So that's still a big number. That's in the billions, yeah, 8 billion. So, but it's way better than 2 to the 63rd. But historically, this is really the mark you have to look at, right? Can I do better than the people that I'm going to play against? That's really what we're interested in, right? Okay, so let's look at, if you had 30 games, if I got 30 games correctly, it'd be 2 to the 33rd, and that's this number. If I got 31 games, it'd be, this is what, half? Yeah, each one is half, yeah, because it's 2 raised to the, yeah. And so then, if I got 32 games, that's kind of on the high end, but occasionally that happens. Well, what if I could get to 34 games? What if I could get to knowing 34 games with some certainty? Well, now I'm in the millions. That's important. Why? Well, I can crowdsource that. I can get enough of us together to produce unique individual brackets in a timely manner that I could get a perfect bracket. You say, oh, Brian, that's crazy. Not so fast. It's been done twice in NCAA hockey. 2 times it's been done by a U of M professor in engineering, as it turns out, but he's done it twice. So with crowdsourcing, right? Brute force crowdsourcing. Now, NCAA hockey tournament is much easier because there are much less teams, yes? And so there's a lot of variability between the talent of the teams, a lot, but it's a little easier. Okay, but this is significant, right? This is down now, if I could get 35 games, I mean, that's millions, that's still a lot, but, well, that's better than Powerball. And people win that all the time. Yeah. Make the news and everything, right? Okay, here's another view. My view is a little unusual, right? Let's look at the historical view. So this is my 64 teams minus number of games I know, minus 1, gets me to this thing, right? And so if I don't know any games, then I get to this, okay? Another view, the sort of traditional view, is I take 2 to the 63rd and I do a little algebra and I get that number, right? So it's the same number. All right, so you go, wait a minute, what did I do? You all follow how I did that? Okay, so I took the 2 and wrote it as a 1 over 0.5, right? So then I flip it, put it on top of the negative sign, and put the negative in the export, and I get that, yeah? So historically, that's how people think about this. Different than my view, they think about it this way. So now, instead of thinking about it as the number of games in my formula n minus k minus 1 and getting these things, they think about it this way, right? Instead of 30 games effectively relates to about a 70% probability, right? Because when I'm looking at it this way, I'm thinking about it as the probability I correctly choose each individual game, versus my view is more, I'm going to do it or I'm not going to do it. This is a sort of overall thinking, like this is completely random, 50%, completely random, whether I get it right or not. This view says, if I can be right 70% of the time, then I get this number. If I can be right 70% of the time, 70%, all of these are really close to 70%. So when you talk to these people who do this professionally or do this as their experts, they'll talk about success rates of being in the 70%. That's the way they talk about it. And the reason they're doing that is because they're using this view of that probability problem. They're really thinking of it as a sort of average across all the games. So now when you're getting into the 73, 74%, that's where there's something really interesting and important happening, right? So the NCAA uses this ranking method called the Delphi method. That's how they make the bracket. Well, let's talk about a different method. Let's talk about the Massey method. So Massey method is named after Ken Massey. He teaches at Carson Newman University. He's a statistician, a wonderful person, great guy. I'm fairly confident if you emailed him, he would be happy to talk with you, right? So he's a good guy. And you can check out his enormous data collection there at themasseyratings.com. So the idea of the Massey method is I'm going to use directed graphs, and I'm going to use some linear algebra and a least squares approximation. And the big part of the Massey method is it looks at the interdependence of all the teams in the NCAA throughout the entire season, whether or not they played each other or not. Right? That's the part that gives this part its power. Okay, so let's look at the MAC. We're in MAC country, right? This is my alma mater, Western Michigan, the MAC country. And this is my Broncos, and then that's Akron over there, right? So here's the idea. I have Akron versus Western in a basketball game. So I put an arrow, and I interpret this to mean that Akron played Western and won. So the arrow points towards Western because Akron beat Western, right? So I beat you, right? That's the idea, okay? So that's the directed graph part. Then I weight the graph by saying 8. And what this literally means is that the final score, Akron, was 8 points better than Western in the score. Now, I don't know what the score was. I don't know if it was 100 to 92. I don't know if it was 8 to 0. I don't know. All I know is that Akron successfully beat Western by 8 points. That's what that means, okay? Now, here's an important point. And this is a very, very common mistake that people make. And we can take advantage of that mistake that people make, because if you make this mistake, your bracket's not going to be very good. And it's this mistake. It's transitivity. We're used to the idea that if A is bigger than B and B is bigger than C, then A has to be bigger than C. That's a transitive property, yeah? That is not at all true in sports. We can think of hundreds and hundreds and hundreds of examples, right? It never means that if Kent State beats Akron and Akron beats Western Michigan, that Kent State would beat Western Michigan by 16. Of course, that's ludicrous. We would never think that, yeah? In fact, we have no idea. We don't know. Western might win this game by 16. Western may win this game by 1. Western may lose this game by 50. We have no idea. Yeah? That's why we play the things. So a mistake a lot of people make is they think, oh, Kent State beat Akron, Akron beat Western, so therefore Kent State has to beat Western. And they make that mistake. We'll take advantage of the fact that they make that mistake, because we won't. Yeah? All right. Here is a simulated season. I just made it up. So we've got Kent State. And I don't know why all of those are Ohio and then against Western Michigan. I'm not sure what's going on there. But those are the ones I picked, right? So we have Kent State, we have Toledo, we have Akron, and we have my Broncos, right? All right, so the way I read this directed graph is, for example, Kent State played 2 games. They played Akron and they played Toledo. Kent State was victorious against Toledo by 7. Kent State lost to Akron by 3. Right? Look at Toledo. Toledo played 3 games. Toledo beat Akron by 17. Toledo lost to Western by 3. Toledo lost to Kent State by 7. So that's how I set that up. That's a directed graph, and I've weighted the edges, right? All right. Fancy, fancy. These are nodes. These are edges. It's directed, and there's a weight. Yeah? Pretty good, Mr. Lee? Is that good? Yeah, he says it's pretty good, yeah. Had to throw some graph theory in there, right? All right. So what I do is I set up this matrix, and I put equal place of the teams. And along the main diagonal, I put their total number of games played. So Kent State played, I forget, 2 games. So I'll put a 2 there. Toledo played, I'm confused. Let's do it this way, right? So Kent State played 2 games. Toledo played 3. Akron played 3. Western played 2. And then in the, that's the main diagonal, right, D1. And in the off diagonal, I will put the number of interactions between the team as a negative. And the net of that will be 0. So Kent State played 2 games. They played against Toledo and Akron. That sums to 0. Toledo played 3 games, once against Kent State, once against Akron, once against Western. That's the idea. So I put them together and you see, yeah? So the total number of games on the main diagonal, and then I have interactions as a negative. So each row will add to 0. Okay, that's great. I call that thing the season matrix, right? That puts the season together. And then let's talk about the net score matrix. So the net score matrix, we're going to solve a system of equations. This would be the right-hand side of the equation. So the net score is simply that. Kent State has a net score of 4. Well, because they beat Toledo by 7, and they lost to Akron by 3, and 7 minus 3 is 4. Yeah? Toledo gets positive 7 because they had this win against Akron by 17, minus 3, minus 7, for a total of 7. And then Akron, let's see, what did Akron do? Akron lost by 17, lost by 10, and then they gained 3. So that's minus 24. And Western got 10 and 3. Okay, so then I set this matrix up. I got a system of equations, and I'll solve for the ranks. The problem is that season matrix is singular. By its very design, it's a singular matrix. And if it's a singular matrix, then I can't solve it, yeah? Okay, well, it's a singular matrix by design, and in fact, it has 1 degree of freedom. So we'd use a little numerical algebra trick, and we take a row, it doesn't matter which row. I tend to do the last row because it's the easiest one to find in the code, right? You could do the first row, that would also be easy, but you pick one of the rows, and you remove the degree of freedom and lock it in place by the simplest mean you can. So I put 1s here and 0 there. It locks that thing in place. It takes away the fact that it's singular, 1 degree of freedom, and it puts no degrees of freedom. And so I'm taking away the parameter by making the first, in this case, the last variable a 1, right? And then solving it. Now I can solve the thing, and I get this rank. Big is best. So my alma mater, the best, yeah. And then who's next? Toledo, and then Kent State, and then Akron's the worst, right? So that's my ranking. Now there's not a lot of teams here, so there's something to be seen pretty quickly, which is if I look at, for example, Western's and Akron's score, if I did 4.375 minus 6, I'd get 10-ish. And if I look back at my score between those two, it's 10, yeah? So there's no surprise there. Yeah, that's the thing. But the thing that this tells me is, what happens if Western were to play Kent State? That's what it's telling me. That's what's important to me, because I'm not going to use transitivity. If Western played Kent State, theoretically, in this model, Western should win about 4.4 points, right? So I would do 4.375 minus this. That's what I should get. That's the idea. Yeah, that's easy, easy enough. There you go. You're going to beat all your friends and family. Yeah. Here's the problem. There's 351 teams, ish. I say ish because there are certain years that teams are on probation, not allowed to play. There are certain years that certain conferences are on probation, so certain teams are, and there's lots of reasons, but it's around 351 teams. So there's the MAC, the Big Ten, the ACC, the SEC, the Big East, and the Big 12, and the Pac-12. That's the Power 7. That's a joke. There's no Power 7. There's a Power 6, and I've added the MAC in there, right? There's 25 more, though, too, right? There's all those. There's a lot. There's a lot of them. Okay. This is what the real thing looks like. About 6,000 rows, about 351 columns. So roughly, every team plays between 30 and 36 games-ish, depending on how far they go in their own conference championship, roughly. Some teams are invited to play in these sort of Christmas tournaments, so they play a couple more games than other teams might get to play, right? So there's a varying amount. So if you take 351 and you multiply it by 30-ish and divide it by 2, that's where you get the 6,000, right? Because each would double up, so you only need about 6,000 rows. And then you have a rank matrix, which would be all the teams listed, 35 rows, 1 column. And then if you multiply these two matrices together, you'll get a result of the scores, right? All right. So I labeled them S, R, and N. And then the idea is you take the transpose of S and multiply that on the left of the left and on the left of the right. This is a common linear algebra process. And then what I get is a 351 by 6,000, because it's a transpose of S, being multiplied by 6,000 by 351, I get a square matrix, 351 by 351. And then over on the left-hand side, or the right-hand side, I get 351 by 6,000, the S transposed, times my net score matrix, and I get this 351 by 1. And so now I have a square matrix, 351 by 351, being multiplied by 351 by 1, and 351 by 1. And then I take, this is the notation, I take the inverse of that square matrix and multiply that to the left of both sides. Over on the right-hand side, it's still there. On the left-hand side, it'll simplify away and just give me R. Now in practice, no one does it this way, right? This would be a terrible way to do it numerically, but notationally, that's the way we think about it. Yeah. So there are lots of methods you would use. I use a computer, but there are lots of methods you would use built into the computer so you get good numerical accuracy. This is the definition of the least squares method, right? So that's the least squares line. Right? Now we don't often teach our students it that way. We teach it a little differently, but from a numerical algebra and from a linear algebra standpoint, that's the definition of the least squares method. All right, so that's great. Now we'll add some weights. So Massey had the Massey method. Chartier adds weights. This is Tim Chartier from Davidson College, and you can check out his great accomplishments. He's going to come in 2024 here to GRCC and be the keynote speaker for Mishmatic in 2024. So we're excited to welcome him in a couple years. So here's the idea. I have a 34-game season-ish, right? Somewhere around 34. And I break it up into segments. So this example, I did half, right? And then, I weight one of the segments more than the other. So the first half of the season, I weight with some factor, and then the second half of the season, I make it more important. And the idea is, what a team does early in the season may not be as important as what they've done the last few weeks, right? That's the idea. What have you done recently? That'll help us, yeah? That's the idea. Well, what if we did it into 4 sections? So I did the first 15 games, got some sort of weight, and then I did the next 10 games, got a little more weight, and then I did the next 5 games, got a little more weight, and then here's the conference championship. It gets the most weight because that's what they've done the most recently. Yeah, that's the idea. Or maybe I think the conference championship's not going to be that difficult for them, so don't put a lot of stock into what happened there, but put a lot of stock in what happened in the last 5, 6 games of their season, right? Infinitely many choices on how I want to weight. Maybe I weight home teams. How do they do at home versus away? That's a big deal, right? How do teams perform on the road? How do teams perform at home? Neutral sites. The theory is all of the NCAA tournament is at neutral sites. How does your team, how do teams perform on the road at places that are away from their own home? That's a big deal, especially for college students. You're not eating your home cooking food, right? I mean, that's a big deal. And the whole tournament is at neutral sites. So maybe we look at how they've done on the road, how they've done neutral sites. How did they do in their own conference? They killed everybody in their own conference, beat them by 30 points. But their conference isn't very strong. So I weight the conference. How well do they do in there? Closely matched games. How do they do in games that are really close? How do they do with winning streaks? Did they get really hot? Did they pull off 10 wins in a row and then lose 5 and then win 10 more rows, right? All of those things are factors that I can weight in my decision making of whether or not teams are going to win or not. How many juniors and seniors do they have? This is a huge deal right now with the transfer portal. How many years have those student athletes been on that team? Were they in the NCAA tournament last year? How well did they do last year with that same core group of students? Or is it all new people? All of that is important factors, right? This is crazy, but look, social media. Can I weight social media? How much positive energy, how much positive press is a team getting versus negative press? Right now, every ranking method you make in America, right now would put Alabama at the first. I wouldn't put them there because they've got some serious problems going on in Alabama right now, right? So I look at their social media. What can I gather from their press releases? What's happening with their students? All of those things are important factors. What their mascot is, right? We should weight the dogs if they have a dog as a mascot, right? The team colors, the uniform colors. Should we weight the uniform colors, right? Okay, so maybe the dogs is a bad idea. But the rest of them are pretty good, yeah? All right. So how do you get involved? You've been sitting here talking all this, and you're showing me the 6,000 row bracket. What am I going to do with that, right? Okay. So the first thing is you just pick a site. Here's kind of the top 4. ESPN, CBS Sports, Yahoo, Sports Illustrated. Right? There are many, 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 many more. You pick a site. What's cool about many of these is you can play in the big pool with everybody, and you can also make a private game. So if you want to play just with your friends and family, you can enter that private game, and they'll do all the calculations for you for free. I mean, you have to watch the ads, but for free, right? And so you could have your church group or your women's group or your Sunday morning volleyball group or whatever you want, right? All of those, you can make a little league, your neighborhood, your math club, whatever you want, and have your own league, which is really nice. They let you do that for free. So you can play against each other. Then you can go to Davidson March Madness. This is Dr. Chartier, Tim Chartier's website that he sort of works with his students. So let's pull up that website and see what that looks like. So this is, when you get into there, they have the choice for men's madness and women's madness. And they make this nice little disclaimer down here, which is nice. It's get ready for March Madness. Use the ideas that have helped create brackets that have beaten 99.9% of competitors in ESPN. So millions and millions of people, 7-8 million people, enter ESPN's bracket. And these ideas, this website, consistently beats 99.9% of everybody else, right? Which is a big deal. But it's not 100%. Right? I had a bracket last year. I finished 402 out of everybody at ESPN. That's the best I've ever done. That's pretty good, right? But obviously, someone did better than me. Man, I got to play again next year, right? Well, that happens. Okay, so I click, let's just do the men's. And when I click on the men's, I get to choose my ranking type. He has 3 listed here. The Cooley ranking we didn't talk about. It's effectively the same as the Massey method-ish, except that it doesn't consult score differential, just wins and losses. And then the Massey method, which we talked about, and then the seeded die. So the seeded die is just based on the seeds, right? You put so much weight on every seed, and it's kind of a random fun generator thing. All right? And so let's pick the Massey method. And then there are some weighted options here for you. There's uniform weight, so that means every game that they played is exactly the same. Then there's this logarithmic weight over time. So at the beginning of the season, it's what it baseline, and then it logarithmically goes up to the most important at the end of the season. And then you can do the same thing with linear, on a linear path. And then you can choose your own intervals, right? You can break up your own intervals as many as you want. Do it. So for fun, let's do uniform weight. And then you get to pick the year. So if we look at 2023, this year, and then I can put the number of teams I want you to print out for me, and then I can cap the largest margin of victory. There's something to possibly saying, all right, if you beat a team by 50 points, that should count the same as if you beat a team by 10 points, right? There's a way to sort of cap the blowouts, because who knows what a blowout means. Maybe it means something, but it's an idea, it's an option to cap or not to cap, right? You can weight home team, you can weight away team, you can weight neutral sites, right? There's some options. Not all the options are there that we talked about, but there's several there. So let's just run it, and then what it does is calculates for you a ranking. So here it has Houston as number 1 and Alabama as number 2, and so on and so forth. And if you tell it to print out all 350 teams in the NCAA, it would do that. I ask it only to do 20, right? So there you go, makes the ranking for you. Now if we look at last year's, something is kind of neat. If I go to 2022 and hit submit, it'll take it a second. So from what I understand, Davidson's server collects the data for this year, And then if I ask it for a different year, it actually goes to Massey's site and grabs it from Massey and brings it into their server and does it just this time. So if you're asking for old years, it takes it a minute to do it because it has to go get the data from Tennessee, right? Yeah, to do it. But it did it pretty fast still, pretty good. But the cool thing about that is it will actually populate the bracket for you, right? So it takes all your rankings with the seeding. Now it's not going to do that yet for 2023 because that's not up yet. But eventually, here very soon, once all the seeding is announced, they'll program that to get it up to date. And then your ranking choice gets put here. And that's basically it, right? So you can use their built-in model to get an advantage over your friends and family. Now the caveat about this is, as the word is getting out, right? People work really hard at making math accessible to everyone. No more people have access to this, right? So if we all did exactly what was written there, we would tie, yeah? Well, that's not any fun. Okay, so that's the truth of it, right? You can have all the analytics you want. The analytics get you a long, long way, but there's still expertise. They're still carefully looking at individual games. They're still carefully saying, now wait a minute. This choice, again, I see this year, oh, that's from 2022. If I look at 2023, now it's probably got to dump, it probably has to dump all the data and bring it back. If I look at the choices from 2023, you know, there's some teams up towards the top there that very recently are having trouble, right? They're losing players. And if those players, these top players, don't get to play in the tournament, well, what does it mean if you have top players not be able to play? Well, I don't know what it means. I just know that what's happened up until this point is less meaningful, yeah? And that's the difficult part about ranking methods is, yes, we're doing very instantly, but, as things happen throughout the season, it can be a challenge to understand what they mean. The perfect example of that was in the COVID seasons. These ranking methods produced these ranks that were worthless because the teams were very isolated on who they played. Certain teams only played like 10 games and other teams played 15 and some played 35 and some of them never got to play out of their conference and some got to play only out of their conference. It was a big mess, right? So you make a ranking method that who knows what it means because of the fact of this sort of style, because it's not a true picture. So my advice is you do a ranking method which will get you a long ways. Like just what we did there is going to beat naivety to death, right? It will beat randomness to death, no problem. But as the word is getting out, as more and more websites offer a free bracket, the supercomputer is going to print out a bracket for you, right? AI is going to make a magic bracket for you. As all of those things are happening, then the field is getting tighter and tighter and tighter. And you're more variability, right? And so if you really think about the weights and experiment with the weights and do a good job with the weights and prod and pry for secrets about the weights, right? Then you can easily get into this 99.9% percentile and region, which is great, right? So go to March Madness, make you a rank, make you a bracket, and win a new car. How about that? Well, excellent. Thanks for coming. I really appreciate it. Enjoy the month of March.